Welcome to lesson 7.37, area of triangles and rectangles, part 2. Last time we studied triangles, we had Dr. von Lichtenstein. I don't even know if that's his name. Dr. von Stumpton. Can't think of it. I tried to get him here, but he just wasn't available. So I'm going to guide you through area of a triangle and understanding this concept today. Anyway, as we look at a triangle and understanding how it works, we first need to understand these ideas. We have the idea of a base of a triangle, which is always the bottom part of the triangle here like that. And to find area, we need to understand the height of the triangle, which is most often shown with a dotted line. Now this isn't always the case because if you have a right triangle that its base and height, its base makes the 90-degree angle right here, this becomes the base, and then the height actually becomes our side right here, right? And so there is no dotted line in that case, right? And there are other cases where we can find the base of our triangle, but there is no known height, because to go from here to here like this, that's actually not the full length because of this obtuse angle. And so sometimes that height is, that's not what I wanted. Height is actually drawn outside of the triangle itself. Regardless of the way that the triangle is positioned, we want to be able to identify these different pieces. Where is the height? Where is the base? How does this all work together? Now we utilize this together with this formula. The formula of area equals 1/2 base times height. Now 1/2 base times height is one way to look at this. Sometimes people look at this from a slightly different perspective, and they put base times height divided by 2. And there are advantages of using both ways. For instance, if one of these two numbers is an even number, it's easier just to take half of that number and then multiply by the opposite, right? Compared to if they're both odd numbers, then it might be easier to use this method instead. It's, in the end, it can become a preference. It also has to do with the size of the numbers also, and just what makes more sense in your head. So let's try this out. We have a triangle here. We see that we got some sides. We got 8 centimeter side, 15 centimeter side, and 16 centimeter side, and a height of 9 centimeters. So we want to find the area. So if I want to find the area, I'm going to take 1/2 times the base. The base in this case is 16, and then multiply by the height of 9, like that. And that's my formula. Now because 16 is an even number, I'm going to just take half of 16 right away and get 8. And then take 8 times 9 to get an answer of 72. Add my label, it's area, so it's squared, and so I have that idea. Right. Now I could have taken 16 times 9 and divided by 2, as described in this method, but in this case, while it's doable, it would work. This method, in my mind, was quicker and easier, right? So we have that idea. So that's looking at triangles. The other part of this lesson is all about rectangles, part 2. And this part of rectangles is when we take complex shapes, such as the one on the screen, and you have to find the area of this. We've already talked about how to find perimeter of these complex shapes, but now we want to talk about area. If I wanted to find the area of this shape, I need to break it down a little bit, similar to how we broke it down in perimeter, but slightly different because, of course, now we're finding area. And so the easiest way to do it is to kind of find your divisions. Now I could make a division coming across like this, and now I kind of have 2 new rectangles. I have this rectangle, and I'm going to put a triangle just to differentiate them. I have these 2 rectangles. But as I do this, the question is, can I solve for this? Right? I definitely take 5 times 13 to find L triangle, but to find 10 times our unknown, right, I'm going to have to do a little bit of math to figure it out. So 5 times 13 gives me an answer of 65. And, okay, now we got to bring back in our idea of perimeter. Since we know the full length from here to here is 12, that would mean that this whole length, like this, is also 12. So we can subtract this 5 and find out that this is actually 7, right? This length right here, right? So from there, then, we can now take 7 times 10 and get an answer of 70. But we're not really done yet. We haven't really found the area of the whole shape. We've just found the area of sections of the shape. And in that case, then, we're going to add these two numbers together and get 135 feet squared. Now, that's one way to look at it. And that might actually be the easiest way to do it. But maybe in your mind you say, well, why don't I try and do some bigger numbers rather than those smaller numbers? Why don't I just draw a line like this and cut it like that? Now I have two small rectangles in that case. Okay, so now we got 12 times 10, so that's 120 here. But now we got to find this length right here. So we're going to take the 13. That's not a 1.3, it's just in a race, I guess. 13, and we're going to subtract it from the 10 up here. I'm going to change colors just so we can recognize a little better. Okay. And that's going to give us an answer of 3. And now we're going to take 3 and multiply it by 5 and get 15. Now, as we look at the two examples within the video, you might say, well, this is definitely, in my mind, easier math than taking 5 times 13 and 10 times 7. And so it's kind of a relative thing as you determine whether you go with this line or this line. Right. But both will get you to the correct answer. All right, then your sample problem for the day, of course, is a little bit more complex. Making you challenge you just a little bit as you work with one of these complex shapes. All right. Wait, I'm here. Don't start the lesson. I'm coming. I'm ready to teach it now. Oh, sorry, doctor. We just finished the lesson. We'll have to have you back a different time. Ah, rats. Well, kids, have a good lesson and have fun with triangles. Until next time, that's lesson 37.